Good day, my dear students. You're welcome back to class. In our previous lesson, we discussed inverse variation. We said inverse variation means an increase in one quantity leading to a corresponding decrease in another quantity. And a real-life application of inverse variation is seen in the relationship between speed and time, where an increase in your speed will definitely lead to a corresponding decrease in time. Well, today we shall be considering number system, and we shall dwell more on changing from one base to another. Well, at the end of this lesson, you'll be able to convert from one base to another. Say from base 2 to 3 or base 3 to 10, whichever way it will be presented. Introduction. The number system is a system of naming or representing numbers. There are four major types of number systems. They are the binary, decimal or denary, octa, and hexadecimal. Binary numbers are expressed in base 2. Decimal or denary numbers are expressed in base 10. Octa numbers are expressed in base 8. Hexadecimal numbers are expressed in base 16. Number system has its real-life application in information technology. If you want to know more, you can check that in your computer science. Considering changing from one base to another, you must note that to do so, you must first of all convert to base 10. Then you convert from base 10 to the required base. We'll take examples to buttress our points. Example 1. Convert 1101 in base 2 to base 10. Solution. You first of all expand the digit as follows. Now the last digit is 1, meaning you have 1 raised to power 0. The next is 0. You have 0 raised to power 1. The next is 1. You have 1 raised to power 2. And the last one is 1, meaning you have that 1 raised to power 3. And the expansion is done like this. You have 1 times 2 raised to power 3 plus 1 times 2 raised to power 2 plus 0 times 2 raised to power 1 plus 1 times 2 raised to power 0. This will give you 1 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1. And this will in turn give you 8 plus 4 plus 0 plus 1. And your final answer will be 13 to base 10. Meaning, when you convert that given binary number, it will give you 13 in base 10. Example 2. Convert 25 in base 10 to a binary number. Solution. We'll have to divide 25 by base 2. That's 2. And this will give you 2 into 25 will give you 12 remainder 1. 2 into 12, 6 remainder 0. 2 into 6 will give you 3 remainder 0. 2 into 3, 1 remainder 1. And 2 into 1, 0 remainder 1. Now, when you want to read your answer, you read from below. That's the remainder part of your answer. And this will give you 11001 to base 2 as your final answer. Let's take example 3. Convert 132 base 4 to base 6. Solution. To convert from one base to another, you must first convert to base 10 like I told you earlier. Then you convert to the required base. So step 1, you have converting 132 in base 4 to base 10 first. And this will give you 1 times 4 raised to power 2 plus 3 times 4 raised to power 1 plus 2 times 4 raised to power 0. And if we expand this, you'll be having 1 times 16 plus 3 times 4 plus 2 times 1. Since anything raised to power 0 is 1. And this will now give you 16 plus 12 plus 2, which is equal to 30. Step 2. Though your 30 is in base 10, so taking step 2, we are going to be having 30 divided by 6 to give us our answer in base 6. So 6 into 30, you have 5 remainder 0. 6 into 5, you add 0 remainder 5. And this will give us our final answer as 50. That is when you read the remainder part from below. So 132 to base 4 is equal to 50 in base 6. Example 4. Convert 101011 base 2 to a number in octa, then B to a number in base 5. Solution. Remember that you always convert to base 10 first, then later to the required base. So we are going to be converting 101011 to base 10 first. And this will give us 1 times 2 raised to power 5 plus 0 times 2 raised to power 4 plus 1 times 2 raised to power 3 plus 0 times 2 raised to power 2 plus 1 times 2 raised to power 1 plus 1 times 2 raised to power 0. And this will in turn give us 1 times 32 plus 0 times 16 plus 1 times 8 plus 0 times 4 plus 1 times 2 plus 1 times 1. And we'll have 32 plus 0 plus 8 plus 0 plus 2 plus 1, which is equal to 43 in base 10. This is just the first stage of this answer. Having converted to base 10, now we can now move it to the required base, which is octa. So we are going to be dividing 43 by 8. And we'll get 43 divided by 8 as 5 remainder 3. Then 8 into 5 will give us 0 remainder 5. Now reading your answer from below, you have 5, 3, that is 53 to base 8 as your final answer. Then let us solve our B part of the question. You already know that if you convert 101011 base 2 to base 10, the answer will be 43 in base 10. So we are going to be considering the second step, that is dividing 43 by 5 to give us the answer in the required base. And if we do so, we have 5 into 43 as 8 remainder 3. Then 5 into 8, we are going to have 1 remainder 3. Then 5 into 1, 0 remainder 1. Now reading your answer from below, you are going to have 133 to base 5 as your final answer. I believe we have understood changing from one base to the other. But if there be any questions, you can raise them in your note and question box. Also have a classwork for you to do in the course of this lesson. Thank you.